Hey guys, we're back with the notes for 10.5. We're going to be doing properties of logs, basically how to expand them and how to put them back together if they are expanded. So if you'll pause the screen, copy the top 3 rules, and we'll get started. Perfect. So you'll notice you have a product, quotient, and power property. Basically anything that is being multiplied together in here, you are allowed to separate and change the multiplication to adding. If anything in here is dividing, you can break it apart into separation with subtraction. If anything is being raised to a full power, you can bring it out and put it back into the front so that it is multiplying. Those are going to be your 3 main rules. Biggest thing I can remind you is whatever your base is, and so let me kind of make that yellow. Whatever your base is has to stay through the whole thing. Okay, so that is not ever changing. Let's go ahead and get started with a couple of these so you can see what I'm talking about. All right, so if I look at problem number 1, I'm keeping the base the same. So I'm keeping log 2, but now I'm going to take this 4 and the x, they're multiplying, put a dot in there. So I'm going to do log base 2 of 4 and log base 2 of x, and I'm going to add those two things together. That's it. I just separate the multiplication into a long adding problem. And that's it. That's the end of the problem. Okay? Let's look at number 2. This problem is division. So I'm going to take the same 2 pieces that are dividing here, and I'm going to start with the first one, 3, and log of 2, and I'm going to subtract them to represent the subtraction. Make sure whatever you start with is from the top, whatever you are subtracting is from the bottom. There is no base. Remember, we just assume that that's a 10 if you're in a calculator, but we would say log of 3 minus log of 2. That's it. Nothing else. Okay, this one, I have that exponent of 2, so I'm going to move it to the outside over here, put that 2 out in front, and then I'm going to keep the x the same, log base 2 of x. The x isn't multiplying with anything inside, so that is how we could write it. Another way you could look at that is if this was log base 2 of x times x, which is all x squared means, right? Then you could think about it like log base 2 of x plus log base 2 of x. And whenever you have 2 of the same things, we add them together and say 2 log 2 of x. So you can kind of see it goes full circle of how you're getting that. Okay. If you need to copy anything down for problems 1, 2, 3, go ahead and do that now. We're going to move into problem 4, 5, and 6. All right, I'm actually going to start with 5 because I'm going to use 4 and 6 to compare. All right, so on problem 5, you could actually think about this problem as saying half of x is the same as x divided by 2. Might be a little bit easier way to write it because you would not really want to create log of 1 and then divided by log of 2. Okay, so let me show you what I mean by that. So if I keep the base the same, I'm keeping the base 4 every time, then I can say I'm going to do log base 4 of x minus log base 4 of 2. So I'm taking the division that's over here and I'm separating that into the subtraction. Okay. If you were writing this from the original multiplication problem, what you would have done is say log base 4 of 1 plus log base 4 of x, because those two things are multiplying, the numerators are multiplying, and then you could have subtracted log base 4 of 2. Now, the difference is that if you take log base anything for a 1, that whole thing is just 0. So in reality, this answer and this answer are the exact same thing. Log base anything of 1 is just a 0, so we don't really need it. That's why I kind of suggest that if possible, if you're doing like 1/3 of x or 1 over anything, go ahead and multiply the pieces together first before you expand it so you're not doing extra work. Okay? All right. Let's go ahead and look at 4 and 6. I want to kind of compare those at the beginning so you can see them. All right, on number 4, there is an exponent, but the exponent only belongs to the y. On problem 6, there's an exponent, but the exponent belongs to the whole parenthesis. It belongs to the 3 and the x. So what we do with that is going to depend on who it belongs to. So let's look at number 4 first. Number 4, I have 3 different pieces in here that are all multiplying together. So when I write these out, I'm going to have log base 3 of 2, log base 3 of x, and log base 3 of y. Now, all of those pieces are adding together because they were all multiplying, but that 3 only applies to the y. So when I write that 3 out, he is only going to go on the front of the y portion. Okay, this would be our answer. All right, I'm going to compare that to number 6 now. So on number 6, that 3 belongs to the whole problem. So you have 2 different options, and I'll show you both of them. Let me highlight this real quick. You definitely want to make sure you understand you have log of 3 and log of x, and they're adding together because it's multiplication. But you could do this 2 different ways. You could say that 3 goes with both of them, so 3 log 3 and 3 log of x, or you could say he belonged to the whole thing, so 3 and then a big parenthesis, and you could go back to this. Log 3 plus log of x. Okay, both of these mean the exact same thing. One is not more correct than the other. It's just a matter of how you see it. In a solving problem, this would probably be the easier option to work with. Okay, all right, again, either one of those answers would work for us. If you need to pause, write down anything for 4, 5, and 6, go ahead and do so now. We're going to look at 7, 8, and 9. Okay, all right, let's start with 7. I'm going to kind of go in order. So I notice that I've got some multiplication things on top. Let me make a smaller highlight there. Got some multiplication going on top. I've got an exponent here, an exponent here, exponent here, and I've got a division piece going on the bottom. So we've got quite a few pieces here. I'm going to start by putting that big 3, this guy, on the outside. Okay, so I'm going to start with him. I've got a 3, and I'm going to do one of those big parentheses before I start expanding this, all right? I'm going to do a log of all the pieces that are on the top first before I do my subtraction for the division. So I have a log of A plus I have a log of B and in this case, the B has an exponent. So this 3 right here is going to squeeze right in here. I want his exponent to only belong to the B. Okay. All right, let's look at our next piece. Now that we have all of the top part, now I can go ahead and switch to subtraction. So I'm going to subtract what's on the bottom. So I'm doing log of C, and then my C has an exponent, so I'm going to scoot this over just a little bit. And I'm going to put this 5 right here in front because he only belongs to the C. All right, once I have that piece done, now I can close out my parentheses. That whole thing is what was being raised to the 3rd power. Okay? All right, just to play devil's advocate, just to show you another option, you could have distributed that 3rd exponent to everybody, and I'll show you what that one would look like now. So let's say you had distributed this to everybody. You could have done 3 log of A plus 9 log of B, and then subtracted on the bottom, 15 log of C. That answer is the exact same thing as if I had distributed a 3 all through here. Okay, it's the exact same process. I do not care which way you go with it, as long as you are consistent. Okay, so as long as your answer comes out right, I don't care if you do this way or if you end up with the color-coded version on the bottom. It's just kind of your choice. Okay, all right, let's go to number 8. Number 8, remember that taking something to a square root is the same as raising that whole thing to a 1/2. A square root is the same as a 1/2 exponent. So I'm going to highlight that yellow just so you remember this is the same thing. All right, so if I'm looking at my pieces, I've got an a that's multiplying, so we're going to go log base 7 of a. That a has an exponent, that's a 5. So I'm going to put the 5 out front. And I'm multiplying him with the b, so we're going to do the same thing. So plus log base 7 of b. The b does not have an exponent, but I do have one large exponent. So I'm going to go ahead and wrap this whole thing in parentheses and put that large exponent all the way out here in the front. Okay? Remember, if you wanted to distribute that exponent first and do it separately, the same answer would have looked like this. 5 over 2 log base 7 of a plus 1/2 log base 7 of b. Either one of these answers is the exact same thing. Okay? I tend to prefer this one, but it does not matter. Both are the exact same correctness. Okay? Let's look at 9. All right, so we are doing a 5th root, which means that that's the same as log of b squared c over d to the 4th to the 1/5. I don't care if you distribute it out first or if you go individually, but I'm going to go ahead and put that 1/5 out front. Big long fraction, or big long parentheses, sorry. All right, I do have a 2 that's going to go with my log of b. I am multiplying that with a log of c, so we're going to use adding. And then on the bottom, I'm dividing with the d, but there is an exponent. So we're going to go minus 4. The 4 exponent only belongs with the d. So log of d. And again, if you had distributed, it could look a little bit different. Otherwise, this is my final answer. All right, if you need to pause anything for the top 4 through 9, go ahead and do that now. Perfect. Now that we're on to the bottom part, we're going to use the next 3 lines to figure out how to put it back together with what you started with. Okay? So we're condensing it. If you ever see addition, notice that that means we're going to multiply it back together. So I keep the base, log base 2, and now 4 and y are going to go back together with multiplication, 4y. That's it. You're done. On here, if you notice you have subtraction, then you're going to be putting your pieces back together. Same base, so log, except now you want to write it as a fraction, 3 over 4. That's it. Let's go to this one. If you have a number out front, you will want to use it as an exponent. So we would say log base 4. Make sure that you are keeping it on the parenthesis or on only this section. So you wouldn't be saying 5 squared like this. You would be saying it like this, 5 squared. Or in other words, this one would just give you log base 4 of 25. Okay, and you could go either way with that. All right, that is your top row. Go ahead and make sure you have that copied down. We're going on to the next page. Perfect. We have 5 left. All right, all of these pieces on this problem for number 4 are adding. So all the adding pieces are going to go back together in one long multiplication. So log base 2, keep the log the same, and we're going to say 2xy. All the multiplication goes right back together. This one's a little bit different. You are going to be making sure that this part and this part multiply together, but these two guys have to divide from each other. So that you have to be kind of careful on that. So we're doing log of 3, and 3 is going to multiply with x over 5 because those two pieces have to subtract. Okay? If you wanted to write that a different way, You could think about putting that back together. So the 3 and the x are going to add. So 3x. And the 5 is going to divide. He's the only one subtracting. Okay. If you ever have a minus right here, you do have to think about distributing it. But these two pieces are exactly the same. Okay. So you could say 3x is multiplying because they were adding. The 5, because he's subtracting, he's the one that's on the bottom. Okay. All right, let's go to number 6. Number 6, that 4 exponent, he is out front of the whole thing. So he has to be on the whole parenthesis. The 2 and the z, they are adding. So they are going to multiply back together. We're going to end up with log 2 in parentheses. You're going to put the 2 and the z back together. And that whole thing is going to get raised to the 4th power. Not the whole log, just that 2z. Okay? All right, that's our final answer for that one. If you need to pause, write down 4, 5, and 6. Go ahead and do that now. We have 2 more problems left. All right, number 7. Again, make sure you know who goes together. So we know that these 2 guys are going to multiply back together. We know that this half only belongs with the x, and this 3 only belongs with the y, and this 2 only belongs with the x. Okay? So if I put those back together, starting with log of a, the x and the y are going to multiply. So x and y are going to multiply. This x over here, he's going to subtract. Or sorry, he is subtracting. He's going to divide. And when you look at the exponents, you have to match them up. So the 1/2 goes with the x to start. The 3 goes on the y to start. And the 2 goes on the x at the bottom. Okay? This is a full final answer. If you wanted to wrap it in parentheses, you could. Don't have to. If you wanted to simplify the x's, you could. Don't have to. Okay? This is a final answer. Let's go ahead and look at the last problem. All right. We've got a couple of grouping going on here. So let's make sure we know. We definitely have a fraction for an exponent. We've got an exponent going on out here and an exponent going on out here. We've got 2 subtractions. Okay? What that means is this guy is going on the bottom. This guy is going on the bottom. The one that you start with is going on the top. So we're going to go kind of slow through here. Definitely starting with log of b. I'm going to set up a parenthesis so that I know where everybody's going. Okay? The guy that I started with on top, x plus 2, or 2 plus x, sorry, he is going to get raised to his exponent. So he is raised to the 3 over 2. If you wanted to do square root and then to the 3rd power, that's the exact same thing. On the bottom now, I have my y and I have my z. Both of them are on the bottom. Both of them have their own exponents. So the y is to the 1/2. The z is to the 6. They are technically multiplying together because if you had written this a little bit differently, you could have almost said minus and then written them out like this. 1/2 log b of y plus 6 log b of z. So they are multiplying together because they are subtracting from the other guys. Either way you look at it, this is our final answer. Okay? All right, if you need to pause the screen, copy anything else, that is the end of our notes for 10.5. Your assignment is to complete the rest of this page. So sections 6 and 7. 6 is going to be expanding, 7 is going to be condensing it back together.